Have you ever wondered what would happen if you rounded up a bunch of obsessive audio geeks and then locked them in a building with only the instructions to build whatever you want and don't come out till you're done? Well, wonder no further, because LG Electronics graciously sponsored our trip all the way to beautiful Great Britain to tour the R&D and production facility of world-renowned speaker manufacturer Meridian. And this is gonna be a good one, because while on the surface, Meridian's flagship $100,000 speakers here couldn't be more different from the LG XBOOM Go Bluetooth speaker that I'm holding, they have a lot more in common than meets the eye. So let's go have a look, shall we? Oh, right. This video is brought to you by LG's XBOOM Go Bluetooth speaker lineup. Check out the special offer linked in the video description. So during development, they worked closely with Meridian, and not just on the voicing of the already finished product like you'd see in many other co-developed audio products. Meridian was involved in developing the specifications of the drivers and the passive radiators that LG brands as dual action bass. They were involved in the creation of both the vocal and bass enhancing profiles, and they even helped with the physical design of the back cabinet to enhance sound quality. One really cool sort of Meridian special sauce feature is actually on the PK3 here, and what it does is it applies image elevation to raise the perceived source of the sound slightly, since it's so common for people to plunk their Bluetooth speakers on a table next to them or by the poolside or whatever. So, bottom line takeaway from this tour, is an XBOOM Go gonna sound like the speakers that we auditioned when we walked in the door? No. Of course not. Don't be stupid. But the folks here at Meridian are still proud to take credit for bringing better sound quality to the rest of us as well, who can't afford six-figure speakers. Except for one thing, right, the RGB lighting. They actually didn't want any of the credit for that, no pride. They were very clear, that's on LG. But you know what, whatever. I think it's cool. We'll start with a little bit of history. When Meridian launched their first product in 1977, powered loudspeakers, so ones with the electronics built into them, were only available in the professional world. But while these were expensive at around £2,000, their strategy of using dedicated amplifiers for each driver unit allowed them to split the incoming signal before amplification, avoiding some of the messiness of a crossover. And actually, when the folks here hooked these puppies up to some Spotify, they were shocked at how well they've stood the test of time. So then you fast forward, I don't know, 40 some odd years, and the vast majority of consumer audio devices now are highly integrated, containing not just drivers and amplifiers, but even advanced digital sound processors that can decode high bitrate streams like Bluetooth with aptX HD like this guy, and dramatically improve performance where cost or physical size constraints had previously made decent sounding audio simply impossible. But this is fun. It turns out Meridian knows a thing or two about that as well. Have you guys ever heard of Dolby True HD? Well, long story, but it's a method of compressing high-resolution Blu-ray audio losslessly that was originally called Meridian Lossless Packing. And it was invented right here. Now, the vast majority of product development is done in software these days, but when push comes to shove, you do have to build one and actually listen to it eventually. So to that end, they built what they call the Inner Sanctum, including this anechoic chamber, which is used in combination with more realistic listening scenarios to ensure that every product that they build here meets the standards of a group of golden ears who work together to evaluate how closely the product represents the original recording. Honestly speaking though, for me, it wasn't the admittedly very nice, good job you guys, graphics on the wall here that blew me away. It was the production floor. Now, I've seen a good number of manufacturing facilities, but this one is completely unlike any that I've encountered. For one thing, it's practically a ghost town in here. And it's not like they cleared it out for me or anything. That's apparently just the way that they work. they've got far more build stations and testing stations than they do people to work at them, which they say is perfect for the small batches that they produce for their worldwide dealer network. So without further ado then, shall we follow the journey of a loudspeaker all the way through? Well, you don't really have a choice, but that's what we're doing. Let's go. First up, while they source bare PCBs from an outside manufacturer, a number of years ago, Meridian invested in their own SMT line, which means that whether it's for in-house prototyping for brand partnerships, like the one they have with LG, or, as we're about to see right now, retail product manufacturing, they can build their own boards in-house. So first up then, the board goes into this machine where it gets a coating of this gray, kind of oozy solder paste. That actually gets squeezed through these holes in the aluminum template so that it ends up on all of the contact pads on our bare printed circuit board. Then our board goes into a pick and place machine that automatically places the smaller board components using computer vision to ensure that there are no obvious defects. So then from there, it goes into a second pick and place machine that handles the larger components. So you can see those are on the spools right here. But we're actually gonna stop for a moment here and draw your attention to this Blundell production equipment cabinet here. So this is pretty cool. Some of the DSP and compute chips actually need to be stored under specific environmental conditions, or they can absorb moisture from the surrounding air, which can turn into a steam pocket during the final stage of production and cause damage. The more you know, right? Which I guess brings us perfectly to the final stage, the pizza oven. So at this point here, everything on that board is actually only held in place by the stickiness of the solder paste. Now, of course, I was being a little facetious before. However much this does actually bear resemblance to a pizza oven, it's of course a bit more complicated than that. And in fact, this one here can handle both traditional surface mounts, you know, with the little legs around the outside of the chip, and BGA chips, which have all the solder pads on the bottom. Fun fact, by the way, when you're designing a double-sided board, you have to account for running it through the oven twice. So you don't want to put anything too heavy on the bottom, or it's all gonna fall off when the solder remelts. So here at the other end, out comes our finished board. It sits and cools for a little bit, then gets carried over to this station, where it's scanned by a combination of optical recognition software and real live human intervention. Huh, how about that? Now, you might have noticed though, in that close-up before, that there's still a lot of contact pads that are empty on our board here. Well, believe it or not, a shocking amount of the soldering work here at Meridian is still done by hand. So here we are at one of those stations. Unfortunately, it's not running right now. I did say it's kind of ghost towny in here, but you'll have to imagine it because this is a really old machine, but a cool one nonetheless. So what you do is you press this button right here, and then pretty much there's these drawers that are built into the entire table that come out. You take out the component, and then there's a lens up here that focuses like a red beam onto where you place the component. Then you go ahead and press the next button, you grab the next one, and put that onto your board. You build the whole thing manually like that. Crazy, right? Then you take your finished board and walk over here. This little guy is lots of fun. So if you've ever seen a surface mount component, here's a capacitor. They've actually got super long leads on them, and this allows them to be mounted in multiple ways. Like you could kind of bend them like this and then lay them over on the side, but they don't want that. They want it stuck through, and then they want as little excess on the back of the board as possible. So this little guy right here kind of guillotines off the back of the leads so that they're as flush as possible to the back of the board so they don't short out on anything. Oh, I think we're done. Now we're ready for the solder wave. It's apparently actually what they call it. So the board goes along this conveyor where it gets blasted with flux and preheated. Then it pretty much passes over this pool of molten solder that seeps up into the joints, but like, gross. Look at this thing, it's got shmoo all over the top of the solder pool. We don't want that anywhere near our components. Well, that is where the wave comes in. So it grabs clean solder from the bottom of the pool, and then it runs the bottom of our board over that kind of, well, wave as it passes by. Well, no, not actually cool at all. It's like really hot. Actually kind of dangerous, but like neat. So this machine here is called the Flying Probe. And given Britain's long and colorful history of creative torture devices, I wouldn't blame you for thinking that that sounds a lot worse than it is. But basically, it's kind of like a CNC multimeter. It's got 4 sharp probes that measure every single resistor and capacitor, and then that spit out an error if a measurement doesn't match the expected value. So you can actually see this readout here where it's going around and poking and prodding at all the solder points to make sure that everything is A-okay. It actually takes up to 13 minutes for this thing to test a single board, which I guess in very small volumes is fine, but in mass production, this would be suicide. That's where this tester comes in. It uses a template and then a whole bunch of relays that are in the machine in the back here instead of a CNC probulator to do that same job in about 20 seconds. The only drawback is that these templates cost a lot and they take weeks to make. Why does it take so long, you might ask? Well, because aside from creating all these little probes here in the front that just all stick into the back of the board at the same time, you've also got to, wire it up at the back. And the worst part is that if you change one thing about the design of the board, you gotta make this all over again. So you only do one of these when you are serious about doing larger runs. So then every single board that comes through here goes through one of these machines, which seems kind of inefficient, doesn't it? But I guess that's what kind of stands out about the culture here. No one I've seen appears to be in any sort of hurry to like meet a quota. They're just trying to build the best damn thing, and if you appreciate that and you've got deep pockets, sick, good for you. Otherwise, I don't know, I guess go buy something else. By this stage, our board is very unlikely to blow up if we plug it in, so it moves either as a raw board, a half-built product, a finished product, or some combination of the 3 into human testing land here. That is to say, the land where humans test it, not the land where humans get tested. Anyway, Meridian uses a combination of real AV products and signal generators, some of which were actually designed and built right here to ensure that every input and output works the way that the user would expect before moving the product to the soak area over here, where it gets burned in for hours. All of that is just the electronics though. Now let's take a look at the cabinets. Now, I'm gonna put that down. Meridian is known for their DSP tech, but signal processing is not magic, and good physical engineering principles matter too. So you think those speakers that we saw out there are just made of MDF or whatever? Think again. These high-end units are actually constructed from 3 layers of plywood with an additional layer of aluminum, as well as this weird kind of glue resin stuff, along with a whack of internal bracing. Actually, this is cool. Even the outer glossy coating apparently contributes to deadening the sound waves within the cabinet as completely as possible, so they won't color the sound. And I will say this, if nothing else, it makes for a very impressive demo when they are literally shaking the ceiling tiles of their showcase room with a 5p coin balanced on its side sitting directly on top of the speaker. Finally, every unit gets bolted together and the whole thing gets tested here by an engineer to ensure that there's no distortion, no buzzes, or rattles, or anything like that from the cabinet, anything loose. Then they run a computer check that can be overlaid with a reference frequency response curve to ensure that it matches the golden model that they've got stored away somewhere. Honestly, it's rare to see anything made with this kind of enthusiast level care and attention these days. LG is running a promotion right now on all 3 XBOOM Go models. Their super compact PK3 with full submersion water resistance, their PK5, which features both clear vocal and enhanced bass profiles and up to 18 hours of battery life, and their flagship PK7 with dual tweeters and up to 22 hours of battery life. Go check out the link to the XBOOM Go PK3, PK5, and PK7 in the video description. So thanks for watching, guys. If you disliked this video, well, you can hit that button, but if you liked it, hit like, get subscribed, or maybe consider checking out where to buy the stuff we featured at the link below. Also down there is our merch store, which has cool shirts like this one, and our community forum, which you should totally join.